Good morning, one and all. Welcome to the fourth lecture for Module 5 of the course ME404 Industrial Engineering, offered to the 8th semester Mechanical Engineering students. I am Mathew Baby, Assistant Professor, Department of Mechanical Engineering, Rajagiri School of Engineering and Technology. Now, in this lecture, we'll be dealing with the different kinds of inventory control systems used and also a concept of selective inventory control, where items that are stocked or inventory is controlled based upon the certain criteria or characteristics of the item that are kept or stocked. So we'll talk about selective inventory control and different inventory control systems. Now that we have seen the different inventory models, now we will go into the different inventory control systems. Now there are various types of inventory control systems which are used to order and replenish inventories. Okay, so we'll be discussing a total of 6 different inventory control systems, and in this slide as you can see, we'll be discussing the very first 2 inventory control systems that are commonly used. Now, as I told you earlier, inventory control systems are concerned or used to order and replenish inventories. So the first system that we are going to discuss is a 2-bin system, and this system is generally used for low value, high volume consumption items. Okay, items which are used in very large quantities or being consumed in very large quantities, but each item that has been consumed is of low value. For such items, we can generally use a 2-bin system. Examples for such items might be nuts, bolts, nails, etc. Okay, so initially what we have is we have 2 separate bins which are initially filled up completely. Okay, to the limit we have filled 2 bins separately, and the first bin is generally taken up for use by the user. So when the first bin is completely used up, the user switches the first bin for the second one and places an order for a refill. Okay, so here you have items which are stored in 2 separate bins. Initially both of these bins are filled. Now out of these 2 bins, one of these bins is taken up by the user and it is completely used up. That means all the items in that particular bin is used up, and once it's used up, the user switches that first bin for the second one and places an order to refill the empty first bin. Okay, so the order that is placed, the order for refill will just arrive just before the second bin is empty. So this process is generally continued, and this system of inventory control is called as a 2-bin system. So it's a very simple system that can be used for low value, high volume consumption items like nuts, bolts, nails, etc. Now the second system that is used for inventory control is a minimum maximum system, and this is a system which is used for materials where the demands keep on changing constantly. So here in the minimum maximum system, what we do is we find out the minimum and maximum amount of material to be stocked based upon the requirement, and the safety stock required is also determined. This is because even when during the reorder period, sometimes the stock, due to fluctuation in demand based upon fluctuation in the requirement, sometimes the stock might go below the minimum amount and into the safety stock or the buffer stock. So what you do is here in this particular minimum maximum system, you find out the minimum and the maximum amount of materials to be stocked based upon the requirement, and also the safety stock required is also determined. Now we have to determine the minimum maximum stock because the demand here is not always constant, it keeps on changing, and whenever the inventory reaches the minimum level or the reorder level, an order is placed for a quantity required to bring the stock back to the maximum level. Okay, so you place an order whenever the inventory level reaches minimum or reorder point, and you place an order for a quantity that is required to bring the stock back to maximum level. So from the minimum level, okay, during the order period, whenever you place a reorder at the minimum level, some amount of safety stock will also be consumed. So the total order quantity is a difference between the minimum and the maximum level plus the amount that is consumed from the safety stock during the lead time. So whenever you place an order, you know that the order is not generally fulfilled instantly. So from the time of placement of order to the receipt, there is a time delay. The receipt of the order, there is a time delay, and this particular time delay is what we call as order lead time. So during the lead time also, items are being consumed from stock, and this particular consumption is called as demand during the lead time. So the amount of items consumed during the lead time will depend upon the demand that pertains, the rate at which items are being consumed, and the lead time. So assuming that the demand and the lead times are constant, we'll be able to calculate what will be the demand during the lead time, and this particular value, the demand during lead time, is added to the minimum, the difference between minimum and maximum inventory levels to get the order quantity. So in the minimum maximum system, the inventory level, whenever it hits the minimum level, a reorder is placed for a quantity required to bring the stock back to maximum level. Then this particular quantity required is the sum of, it's the difference between minimum maximum level and the demand during lead time. So the advantage of the minimum maximum system is that different minimum and maximum levels can be defined for different kinds of items. So this is the minimum maximum system for inventory control. So here you estimate the minimum and the maximum amount of materials to be stocked, and this particular minimum and maximum limit determination is due to the fact that the demand usually constantly changes. It's not a demand is not always constant, it keeps on changing. So whenever the inventory level reaches a minimum level or at the reorder point, an order is placed for a quantity that is required to bring the stock back to the maximum level. So this particular order quantity required, as I told you, is a difference between the minimum maximum level, or the difference between the maximum level and the reorder point, the quantity at the reorder point. So that difference plus the demand during the lead time. And the advantage of this particular system is that, as I told you, it is we can set different minimum and maximum levels for different items or different classes of items. So that's the second inventory control system. Now the next inventory control system is the EOQ, or the economic order quantity system. Now this system is generally preferred for the storage and inventory control of valuable and essential items. And here the order quantity is determined such that the total cost of inventory is kept to the minimum. That means the total carrying and ordering cost, the total cost of inventory is kept to a minimum. So we have seen the EOQ system in the different kinds of models. Inventory models, we have already seen what an EOQ system is. So here this particular system does not allow for a safety stock, and when the inventory hits zero when the order is received. So when you place and reorder, the reorder is placed at such a point that by the time the inventory level touches zero, okay, the reorder that has been placed is received. So the inventory is generally becomes zero when the reorder that you have placed is received, and it accounts for no safety stock. And here this particular system assumes a fairly constant lead time. The reorder point is determined by the lead time, and assuming that the demand during the lead time is constant. So here the reorder, if this is the lead time, okay, then This particular figure over here represents the EOQ model. Now, if you have a lead time equal to this much, say the amount T, and the demand during that particular lead time is constant, that is D, that is the demand during that particular lead time. The total quantity consumed during that particular lead time will be equal to D into T. So you will place an order you'll place an order at a point where the inventory level has reached a quantity which is equal to the maximum inventory level, that is the point at which that particular inventory level starts off from. So from here the maximum inventory level minus dt. So that is a point at which whenever the quantity of inventory reaches that particular point, which is maximum inventory level minus demand during lead time. When the inventory level reaches that particular point, you place an order for reorder, and the reorder quantity will be equal to the EOQ. Okay, so here also the reorder is basically to bring the stock back to its maximum level. So the optimal order quantity is what is generally placed over and over again. Okay, now the next system that is commonly used inventory control system is the ordering when quantity is available system. So when there is a bulk material purchase, you see that the sellers or your suppliers offer discounts. So this particular discount is different for different quantities and the frequency of purchase. So here your order is not based upon the level of inventory that you have, but rather it is based upon the discounts provided. So bulk material purchase is generally preferred because bulk material or bulk purchase of items will generally provide you with discounts. So in the ordering when quantity is available is generally used when there is a quantity discount. When you purchase things in large quantities, you're provided with discounts. So you buy based upon the discounts that is available. So that system is called as ordering when quantity is available. So this is the fourth inventory control system. So the next inventory control system is called as a queue system, which is the fixed order quantity and variable cycle system. Now, as the name suggests, in the queue system, the order quantity remains fixed, whereas the cycle time, that is the time between subsequent orders, consecutive orders, they are different. Okay, so in a queue system, queue remains fixed, that and the cycle time or the time between subsequent or consecutive orders, they keep on varying. Now this particular system is also called the continuous review system because whenever you use this particular inventory control system, you have to continuously monitor the stock levels. Okay, and the ordering times, they vary due to the fact that the demand or the rate of consumption of the stock, it is different for different cycles. So whenever the stock touches a level called the reorder level, an order is placed for a fixed quantity of products, and this particular system is generally used for low unit cost, high volume consumption items. Now to explain this particular system, we have depicted the model or the queue model for inventory control using this figure over here towards the right side of this particular slide. So as you can see, this again plots the variation of stock level with time. At time t is equal to 0, we have maximum stock. So this is a point where the stock has been refilled up to its maximum level. So here also we are considering instantaneous replenishment or instantaneous refilling of the stock. So here during the initial cycle, where first we start from the maximum stock level, due to the demand at a constant rate, we assume the items to be consumed, and whenever the order level or the stock level touches a value equal to the reorder point or the reorder level, we start placing an order. Now this particular reorder level can be calculated as the safety stock, this particular quantity. Okay, that is the zero quantity, and then there is a minimum amount of stock that is always maintained, called a safety or the buffer stock. Okay, so it's a buffer stock plus the demand during the lead time. So once you place an order, it takes some time for the supplier to deliver the particular item. So that particular time is called as lead time for delivery. Okay, this is the time interval from the point of reorder, from that particular time period to the time when the stock is received or the order is received. So that particular time interval is called as the lead time. So during that particular time also, items are being consumed in the stock. So there is a certain amount of consumption happening during that particular lead time for delivery also after reorder. So the safety stock plus the demand or the consumption of items during the lead time for delivery, when you add these up, you get the level called the reorder level. So whenever the stock level touches the reorder level or the reorder point has been reached, then you place an order, and then the item will generally reach you, in most cases will generally reach the company by the time the stock has reached or touched the safety stock. Okay, it need not be same. If your lead time for delivery is assumed to be constant, then sometimes the stock level can go into the safety stock as well. So you place an order, a fixed quantity of order, to bring that particular stock back to maximum level. So the order quantity will be equal to maximum stock minus reorder level, that is this particular value, plus the demand during that particular lead time. Okay, so the demand during lead time, you will add that, that will give you the total reorder quantity, and this particular reorder quantity is ordered, and this, once it's received, it's instantaneously replenished back up to the maximum stock level. Okay, so here every time you are ordering a quantity equal to Q, a fixed quantity. So you order a quantity equal to maximum stock minus safety stock. This is the quantity that you generally order. But as you can see here, in the first case, the time interval between subsequent reorders, this is the first point of reorder. In the next cycle, the reorder takes place here. So this is the time interval between the first and the second reorders. Okay. Then the third reorder takes place somewhere here. Here also you can see that the demand is generally varying. So the time interval between these two is different. And the fourth reorder takes place here. Okay. So this is the first reorder point, second reorder point, the third reorder point, and the fourth reorder point. The time intervals between two adjacent reorder points are generally different. This is due to, as I told you, a variation in demand. You can see that the slope of the demand curves or the consumption curves, they are different. So that means the demand is generally different. So every time you hit the reorder point, you make an order for a quantity, and this quantity is generally fixed. Okay, and this quantity is generally asked for every time. So this system, as I told you, is used for low unit cost and high volume items, and is normally preferred when the supplier puts a minimum quantity restriction. Okay, so there should be, if the supplier tells you that there is a minimum quantity of item that needs to be ordered, it is preferable that you have this particular inventory control system called the Q model or the Q system. So here, as I told you, we continuously review the stock levels. Whenever the stock touches the reorder level, we place an order for a quantity Q. Okay, a fixed quantity Q. Now in this particular figure, the fixed quantity Q, the order quantity, is nothing but the maximum stock level minus the safety stock level. This particular difference, that is a fixed order quantity that we generally place over here. Okay, so this need not be always the case. The fixed order quantity might vary, but as I told you, the quantity that you order for a particular item will be always constant. Now the last inventory control system that we will be discussing is called as a P system. Now P stands for period. So in this particular system, there is a fixed time period between subsequent orders or consecutive orders. That's why it's called as a fixed cycle and variable quantity system. So here, when compared to the queue system, the order quantity varies, but the time between two adjacent orders or two consecutive orders, they remain constant. So here the cycle time is fixed, but the ordering quantity varies based upon the demand or rate of consumption of the item in stock. Now this is also called as a periodic review system, where the stock levels are reviewed at constant time intervals. Okay, so at a fixed time interval you review your stock levels, unlike the case where you continuously review the stock levels in the queue system. So in the queue system, you have to continuously monitor the stock levels. Here you only monitor the stock levels at periodic intervals. Now the periodic interval, the interval between subsequent reviews, stock level reviews, is such that the purchase of items is in a sufficient quantity that makes it economical. So if you review the stock levels at very high frequency, or the time between two adjacent reviews, if it's very small, now even if the demand rate is varying from one cycle to another, the problem is you might have to place orders in very small quantities. So sometimes placing orders for very small quantities might not be cost efficient. So the time period between two subsequent or two consecutive reviews is placed such that there is a sufficiently large quantity that needs to be ordered at the time of review. Okay, so in the P system, as I told you, the cycle time is fixed. That means you review the stock levels at a fixed time interval, but the order quantity keeps on varying based upon the demand or the rate of consumption in that particular cycle. So this is why this system is also referred to as a periodic review system. Okay, so in the P system, the time between two subsequent reviews or the cycle time is fixed, whereas in the Q system, the Q is fixed, that is the order quantity is fixed. Okay, so the order quantity Q is just enough to hit the target stock. Okay, it is you order just enough so that the target stock has been hit. So the target stock is generally the maximum inventory level that is possible, that is allowable for that particular item. So you order just enough to hit that particular target stock level. And to understand this particular system easily, you have a figure that depicts how the stock level varies and how and when you reorder when you're using a P system for inventory control. Okay, so in this particular case, you can see that at time t is equal to 0, the stock level is at the target stock level, that is the maximum stock level. Okay, as time passes, you see that the stock level decreases, and from this particular point, this is the start of that particular cycle where where the item has been replenished to the target stock level from the previous cycle. So this is the start of the cycle, this is the starting point for the cycle. Here during this particular cycle, you can see that at a certain point of time after the start of the cycle, you carry out a review of the stock level. So you see that at that particular point of time, okay, there is a certain quantity that is the stock level is at a level that is lower than the target level, that's maximum level. So what you do is you take that particular value. Okay, so you take that particular value here, that is the quantity quantity of stock that exists at that particular point of review. So if you carry out a review at this particular instant of time, say t is equal to t1. Okay, so at t is equal to t1, we carry out a review and we find that the stock level is at this point, so it is deficient or it is lower than the target stock level or the maximum stock level by this quantity. So the difference between these two values will give you a value. Okay, and at that particular point, every time you review, you place an order. Okay, the order quantity will be the sum of the difference between the quantity at the time of reorder and the maximum stock level. So the maximum stock level minus the quantity at the time of review plus the demand during that particular lead time. Okay, so whenever you place an order, as I told you, in most cases supplier will not be able to supply the particular item instantaneously, so it takes some time for them to supply. So during that period also items are being consumed. So what you do is you calculate the demand during the lead time by multiplying the lead time. That's the time between the reorder to the delivery of that particular refill order, okay, or reorder. So the time between these two, this particular time interval, you multiply that by the demand, you will get that particular value, that is the demand during the lead time. You add that to the difference between the maximum stock level or the target stock level and the quantity of stock at the point of reorder. So you add that and that will be your order quantity. So the order quantity here in the first cycle will be the difference between this particular point and this point. This is the total quantity that will be ordered. Okay, so once you receive that particular order, the stock will be instantaneously replenished and it will go back up to the target level. In the next cycle, you can see that the demand rate is generally very high. Okay, the items are being consumed at a faster rate. So here the demand or the rate of consumption is very high when compared to the first cycle. So the next review takes place after a time. So initially that review took place after a time t1. Okay, the next review will take place after a time twice that. So it will be at regular intervals. So this particular point of review, you can see this is the review period. This is the next time that you will again check the inventory level. At that particular instant, okay, you can see that the stock level when compared to the previous review period is low due to the higher rate of consumption. Okay, so what you do is you take that particular quantity, subtract that from the target stock level. Okay, to that you add the demand during the lead time and then the order quantity is fixed. Okay, so here in the second cycle the order quantity is a difference between the level here and the level here. This is the total order quantity. That means nothing but the difference between the maximum inventory level and the inventory level to which that particular cycle goes to. So this is due to a change in the rate of consumption or demand. Okay, so here the reorder quantity is nothing but the maximum inventory level minus the inventory level at the point of review. This is the value. To that you add the quantity that is being consumed during the lead time. So this is the time that supplies lead time. So this particular supplies lead time, you add the quantity that is being consumed. Okay, so during this particular supply lead time, items are being consumed, so add that particular item consumption, which is nothing but the supply lead time multiplied by the demand. So you multiply these two, add it to the difference between the maximum or the target stock level and the stock level at the point of review. So you get an order quantity this. So the reorder quantity here is much higher than the reorder quantity for the previous cycle. Okay, that is because the rate of consumption or the demand is generally very high during this particular cycle when compared to the previous one. That is why we call it as a variable quantity system. The order quantity keeps on changing, but the review of the stock levels, they take place at regular intervals. That's what you see here. Okay, you can see that vertical dotted lines that are represented, they represent review periods. That is a time at which you generally check the inventory level and you place a corresponding order. So review points or reorder points are determined by determined by the time of review. Okay, the reorder point is not always constant, or the reorder, there is no fixed reorder level as in the case of the queue system. So here it is also called as a periodic review system because the review takes place at constant time interval. So you can see that the difference between the time between two subsequent reviews is always constant over here. That's why it's called as a P system or the periodic review system. Okay, so in this particular system, the Q is the order quantity Q is just enough to hit the target stock. Okay, and average inventory levels when compared to the Q system are higher, because the chance of a stock out is generally very high in the case of P system when compared to Q system, because you're not continuously monitoring your inventory level. You do not know when that particular item will go. Sometimes if the demand or the rate of consumption is very high during a particular cycle, like this, here you can see that in the first cycle the stock level at the first point of review was within or above the safety stock level. Okay, and when the reorder was placed, when the reorder was received, it was well within the working levels, so above the safety stock level. In the second cycle you can see that the demand was so high that once they placed the order and received the reorder, by that particular time the stock level has already plunged into the safety stock or the buffer stock. But if we have a case where the demand rate is even higher, or the rate of consumption or demand is even higher, sometimes you may have a chance of generally have a chance of stock out, where you end up with no items in the inventory that can be supplied. So that's a condition might also exist. So here the average inventory levels are higher than the Q system, and this is generally to protect from stock out before the next review period. So this is generally to avoid any kind of stock out conditions before the next review takes place. So here an advantage is that there is easier and less effort on the part of the managers, because they only have to monitor the stock at a regular time intervals. So they know that if they have carried out a review at this month, at the start of this month, if they have fixed the next review period to be after 30 days, so they have to carry out this particular activity of reviewing the stock level only at every 30 days. Okay, so this makes their effort much more easier, and this is generally used for high unit cost, low volume items consumed in lower quantities, but each unit generally costing very high values. And P system is preferred when the supplier delivers or supplier prefers to deliver at constant time intervals. Okay, so now we move on to the last topic in inventory control, and the last topic for module number 5, that is selective inventory control. Now the term selective inventory control, it refers to the variation methods of control from item to item on the basis of some criteria. So here companies or manufacturing organizations, they generally have different kinds of items being purchased. Now all the items are not of equal priority, or they might be of not of equal importance. So based upon different criteria, you will think about classifying the items that are purchased and stocked by a company, and then dealing with each of these different classes based upon the classification criteria or grouping criteria. You deal with these variety in different fashion. So the inventory control for every item that is being purchased and stocked by a company or kept as inventory in a company need not be done in the same fashion. So selective inventory control techniques basically help you to classify items based upon certain classification criteria and divide them based upon their importance or vitality, whatever that might be, based upon the criteria used for classification. And based upon the classifications made, you will be able to adapt or use different inventory control strategies or inventory control methods to control those. So such a system is called as selective inventory control. Now, based upon the criteria used for classification, we have 6 different selective inventory control techniques. Okay, there are 6 different selective inventory control techniques based upon the criteria used for classifying items that are stocked. They are the ABC analysis, the HML analysis, VED analysis, SDE analysis, FSN analysis, and SOS analysis. Now in this slide, we'll see the very first three called ABC analysis. Now in ABC analysis, the items are classified or they are grouped based upon the inventory value, not their importance or vitality. Okay, that is the total value, annual usage value of the items. It is based upon the inventory value that you classify, not based upon what is the importance of that particular item or what is the level of vitality or criticality of that particular item for productive purposes. So purely if you classify based upon the annual usage value, such a classification is called as an ABC analysis. And ABC analysis classifies inventory into three classes: class A, class B, and class C. Now class A consists of items which are high value. That means unit individual prices are generally very high and they are low in number. They are generally kept very low in number. The quantity that is maintained as inventory for these high value items are generally low. So the class A kind of items are the ones that require very high levels of inventory control. So the close inventory control is essential for class A items, which are, as I told you, high value items but stocked in very low numbers. So class A items generally account for 10% of the total items in terms of quantity of total items that are maintained. They only form 10%. But in terms of their inventory value, they constitute about 70 to 80% of the total inventory value. So if you say if you have a total inventory worth rupees 1 lakh, out of that you have 70 to 80% of that value being contributed by just one or two items, which might only constitute about roughly 10% of the total items. So such a classification, such a class is referred to as class A. So class A requires very close inventory control. Now class B items are moderate value and they are also stored in moderate numbers. So they generally constitute about 50 to 20% of the total items. Okay, so the total item quantity, they out of the total item quantity they constitute about 15 to 20%. And class C are those items which are low value but they are kept in very large volumes. So here the value of individual items are low but they are kept in large number. So 70 to 75% of the total items in quantity belongs to class C, but they only contribute roughly around 10 to 15% of the inventory value. Okay, so this is the classification, or this is the basis for ABC analysis, where items are classified based upon their annual inventory value and not their importance to production or their criticality in production. So you have three classes: class A, class B, and class C. That's why it's called as an ABC analysis. We analyze items and place them under classes A, B, and C. Okay, A items, high value, low quantity items. They are generally considered only about 10% of the total number of items that are kept as stock, but they account for about 70 to 80% of the total inventory value. Class B items are the ones where you see moderate value items kept in moderate quantities, and they constitute about 10 to 20% of the total items in terms of quantity. And class C contains items that are low value but they are stocked in very large quantities. So in terms of quantity, they account for around 70 to 75% of the total items, but in terms of inventory value, they only constitute 10 to 15% of the inventory value. So class A items require very close inventory control. Class B requires moderate levels of inventory control, and class C items only require very low levels of inventory control. The second selective inventory control technique is the HML analysis. and this stands for HML stands for high, medium and low. Okay, and this classification is purely based upon unit price. So what you do is you list out the items that are kept as stocked in a company in the descending order of the unit price. So the item that is kept as stock in the company, there might be say 1,000 different items kept as stock in a company. You list them in the descending order of their individual unit price. So the one that has the highest individual unit price is at the top of the list, and one that has the lowest single individual unit price per unit is kept at the low the bottom of the list. And you set limits as to what falls under high price category, what falls under medium price category, and what falls under low price category. So take for example, we have items which are in the price range from price range above 1,000 can be classified as high value items. Between 500 and 500 and 200, sorry, between 1,000 and 200 you can classify it as medium value items, and below 200 rupees unit price you can classify it as low. So what is the basis for segregating high, medium and low price? That is determined by the company themselves. It depends upon what are the types of items and what their prices are. So there is no specific fixed range as to what is high value, what is medium value and what is low value. It is subjective in nature. High value, medium value, low value, the classification and the range specifications are dependent upon the company and the kind of items that they keep as stock. So the cutoff for each category is fixed. It's according to the company. For example, as I told you, any item above say 550 rupees per unit might be deemed as high price items for that particular company. So the classification or the category cutoff for high, medium and low is specified by the company themselves. So this is another way of classifying items and then prioritizing your inventory control. Okay, so you classify them based upon the unit price. So this is the HML analysis, where you analyze items based upon their price and categorize them into 3 units or 3 classes: high priced, medium priced and low priced units. The third selective inventory control technique is VED analysis, and this is purely based upon the importance of an item in the productive purpose. Okay, so VED stands for vital, essential and desirable items. You classify them based upon the importance to production purpose as vital items, essential items and desirable items. Vital items are those items which, if not available in stock, will completely halt or stop production process. So they are very, very important to the production process. Such items are classified as vital items. So the inventory control technique should focus upon these. Inventory control should always ensure that these vital items are always available. Then essential items are items who those when are out of stock, or in situations of out of stock of essential items, it might not stop the production or cease the production, but rather the cost of stock out will be generally high. So you might have to pay a higher cost. The only negative impact on the production process might be higher cost, but it does not result in stoppage of production. So those classes of products are called as essential products. And the third class of items or products are desirable items, where the production is not affected and it may not cause any loss or any additional expenditure. So such kinds of items require very low amounts of inventory control, or the inventory control might be very lax or relaxed for that particular kind of items. So we have VED analysis, where we classify items kept in inventory into 3 categories: vital, essential and desirable, and this classification is purely based upon its importance to production purposes. Now this is a graph that represents how you classify items in the ABC analysis for selective inventory control. So on the x-axis of this particular graph, you can see the percentage of total items in terms of quantity. Okay, so x-axis represents the quantity of items in terms of percentage, and the y-axis represents the value of the inventory in terms of monetary value, money value. Okay, So class A items, they only constitute a very low percentage of the total items in terms of quantity, but in terms of the total money value, they constitute around 70 to 80%. So they are high value items that are kept in low quantities. So their contribution towards the total inventory investment is very high, but they are generally present only in low volume. Now, class B of items, as I told you, then the quantity is generally higher. So in this, according to this particular graph, there are around 30% items, but they constitute around 15% of the total inventory value. Okay, and the class C items, they are the items that are largest in number, say around 50% or so. It might be even higher than that. According to this particular figure, you have class C items that constitute 50% of the total quantity. So if you have a total inventory quantity of 10,000, out of that 5,000 will belong to class C. Okay, and out of that 15%, no, sorry, 75%, 20% will belong to class A. That is, you have a total of 2,000 here, and class B will constitute a total number of 3,000. And if your total inventory value is uh, say 100 rupees, to make the calculations easier, class C items, even though they constitute a total number of equal to 5,000, okay, they only account for rupees 10. If a total inventory value is assuming a total inventory value to be rupees 100, so they only constitute around rupees 10, even though they are largest in number, they are 5,000 in number. Class B item, they constitute in terms of number 3,000 units, but the value is only rupees 15. Okay, and according to this, class A items, which are the most critical ones, which are high price items, they only constitute in terms of number only 2,000 units, but they account for 75 rupees of the total inventory value of rupees 100. So 75% of the total inventory value is accounted for by the class A of items. So according to this, class A items should be, this is essential that you have very close control over class A items and their inventory levels. Moderate levels of control need to be maintained over class B items, and class C items you can have a relaxed level of inventory control. Okay, so this is the graph that shows how you classify items and what is a characteristic of class A, B and C classes of inventory. Now the fourth selective inventory control technique is the FSN analysis, which classifies items as fast moving, slow moving and non-moving. Now this particular classification of items kept in inventory are purely based upon the consumption rate. That is the rate at which these items are being utilized or taken from the stock. So fast moving items are the items where we have high consumption rate. Slow moving ones are the items where we have low consumption rate, and non-moving items, that's the third category, N, which are items which are generally seldom used. Okay, now the FSN analysis is generally used for spare parts management, okay, or spare parts inventory management. So this will generally help you to have a proper location of different kinds of spare parts. So the fast moving goods, items which fall under this fast moving category, they can be generally located near the distribution window or the exit of that particular storage area, so as to reduce the handling efforts. So that is how the FSN analysis basically helps you to plan your storage or inventory location, and that is why it's generally used for spare parts management. It is not used for raw materials, because most of the raw materials used in a company are generally used at a similar rate. Okay, whereas these spare parts that are used by the maintenance division, when you keep spare parts and tools inventory, they are not generally always used at the same rate. That is why you use the basis or criteria of consumption rate for classifying spare parts. So efficient analysis basically classifies items into fast moving, slow moving and non-moving items based upon the consumption rate. Fast moving items are the ones that are high consumption rates, low moving ones with low consumption rate, and non-moving ones are the items which are seldom used. They are used once in a while here or there. So this, as I told you again, is used for spare parts management. It helps you to locate the position of fast moving goods. So the different kinds of goods based upon their rate of usage can be located at different parts of the spare parts inventory storage area. So the next classification or the next selective inventory control technique is SD analysis, which classifies items into three categories: SDE, that is scarce, difficult and easy. This is purely based upon the lead time required in part procurement, or basically based upon the difficulty in procurement of that particular part. Higher the difficulty in procuring a part, generally it is indicated by larger lead times for its procurement. Okay, so based upon the lead time required in procuring the part, we classify them as scarce, difficult and easy. Scarce are those items which have very large lead times. That means from the point of order till the receipt of that particular order, it takes a large amount of time, and these are items that are usually imported. So when you classify items as scarce, you should always focus upon these items when you have inventory control. The items which fall under the category difficult, they have comparatively lower lead times but not very short lead times. Okay, they are comparatively, when compared to the scarce category, the lead times are lower, but they are not as low as the easy category. Now easy category of items, they are the ones which are easily available at very short lead times. So you order, it takes them hardly say a few weeks, 1 or 2 weeks, not more than a fortnight to deliver. So those kinds of items are put under the category called easily available. So it's based upon the lead time required for part procurement. So more effort should be given to items which are scarce. Okay, so according to this, the category called scarce items should be given more importance in inventory control. And the last analysis technique, selective inventory control technique, is called as SOS, which classifies items based upon their seasonality. Okay, classifies them as seasonal and off seasonal. That's why you have SOS. S stands for seasonal items and OS stands for off seasonal items. So seasonal items should be given more importance because they are only available at certain times of the year. For example, if a food processing industry that uses mango as one of the major raw materials, generally mangoes are seasonal items. They are generally more available in more quantity during the summer season. So items which fall under the seasonal category should be the ones that should be given more importance when we talk about inventory control. So here, based upon the seasonality of items, the SOS analysis classifies items as seasonal and off-seasonal items, and seasonal items are the ones that should be given more importance. Now with this, we conclude lecture number 4 for module number 5, and the last lecture, that is lecture 5 for this particular module, will deal with problems, economic order quantity calculation problems for purchase models with shortages and without shortages. So we'll have a session on discussing that session that deals with the discussion of various problems related to EOQ in lecture number 5. With this, we conclude the theoretical topics in module number 5. Thank you.